Yeah, my name is Ingo. Thanks for joining our talk. This is my colleague Florian.
Hello, everybody.
We are both working at a company called Centralized, and Centralized builds web applications all the time. And we are part of the security team, the local security team, which tries to enable developers to build web applications with a reasonable security, right? So, and today's talk kind of fits in neatly with the previous talks because we are also talking about patch management or vulnerability management. And we want to share some insights how we kind of fix that topic at our company. So maybe some of you ask yourself, well, patching, isn't it a solved problem, right? Because, I mean, there's a software you're running, it has a vulnerability, there's a patch, just install it, right? It turns out that's not that easy. Maybe, or probably, many of you remember the ransomware news, especially from 2017. If you don't, maybe this is a screenshot you have seen in the media. Yeah, and these ransomware attacks were kind of successful. Ransomware, you get a malware, it encrypts all your data, and then you have to pay a ransom, mostly in Bitcoin, to get the data back. So the screenshot was from a ransomware called WannaCry. And WannaCry hit the world on, I think it was May 12th, maybe May 15th, I'm not sure about that, in 2017. And it kind of spread in a short amount of time, kind of virally, by exploiting the Eternal Blue vulnerability. It doesn't matter what Eternal Blue is. What matters more is Eternal Blue was fixed by Microsoft on March 14th, 2017. And if you didn't get it already, the patch was there for 2 months, but nevertheless, this WannaCry ransomware, I'm not sure, hundreds of thousands of PCs got infected by that. So if you look at real-world scenarios, it turns out patching is not that easy. It also told us, and probably most of us who have a common attack scenario, we should, from a strategy perspective, worry less about these O days, which are kind of exciting, and get the patching done in the first place, right? So patching is hard. We've encountered it on our own, at least if we have real-world scenarios. But why, right? I mean, another assumption, if you work in IT and spend the Easter holidays with your family, chances are you have fixed their PCs. And you can patch them too, right? So why shouldn't it work in an enterprise which has millions of dollars to spend on that stuff? Turns out there are some constraints. 3 of them I will mention now, which we have encountered. First one is legacy. If you have some sort of grown IT infrastructure, chances are there are old systems, like your CCTV servers or old file servers or what have you. And chances are they run an operating system which is just not patchable anymore. I recently had to see the doctor because of my voice. And guess what? The Windows was kind of XP. I'm not sure if they got the extended support. I'm not that confident, but yeah, you have legacy. Second one, availability. Yeah, you can do patching, and you can patch all your kernels and stuff like that, and then you can just reboot the whole thing, right? This is easy if you have sort of single nodes, which come up pretty quickly again with their application running. But try to reboot these hypervisor clusters, which host like, I don't know, 20, 30 VMs each. People will notice that downtime. And if you have a web application which generates money, it's not that easy to just boot it through. Which brings me to the third point, money, right? Patching causes time and effort and money. And the application runs fine on its own, so why bothering with it, right? So these were 3 constraints that we encountered. And now I'm going to intentionally hand over to my colleague Florian, who will just give you a glimpse into the Centralized ecosystem.
Okay, thanks. It's not about rambling about our infrastructure and how cool we are. As we said, this is about DIY patch management. and we want to share here our past insights into what was going on, and to let you people know that even if it's burning at your infrastructure, it's okay, we've been there, and this is maybe one of the ways you may fix it. And as Christian put it out in the last talk, you can use open source tools, and we did that as well. But before that, what does our infrastructure look like? In a world where we have M tenants, like we have big customers, Fortune 500 customers, we've got legacy customers, we've got customers with legacy approaches, we've got different devices, not only in the setup, like we've got the servers, but also in like, okay, had to have testing devices which we need to manage. So we have a big lot of infrastructure, not only in servers, but in client systems, which means we have M10 stacks, for example. And in the end, we are focusing here on the product of these two, like n times m requirements, but in the real world, it's more like exponential, like m exponentially to m requirements. So this is something you have to keep in mind, like, okay, it's always worse. The thing about it, it's always worse. It's like, okay, it's very heterogeneous. We, at least on the hosting part, focus on Ubuntu and Debian-based systems, but this is not true for all our customers. We also have Windows systems and Mac systems as well. Like, the good thing is that our Unix-based OSs are packaged into VMs and containers, so we are quite far at that shore. And nowadays we also do serverless, which is quite cool because we are getting to a whole new frontier of infrastructure we can manage with whole new methods and techniques. But on the other side, we have to maintain the legacy parts as well. So this means in the end that we've got an inconsistent patch management. So never to sometimes regularly to whoever was looking at the server right now, maybe he didn't get upgrade or something like that, but we can't be sure for sure. So we can fix this problem, for example, then with commercial scanners, like get ourselves a custom off-the-shelf product, like the big companies have it. No, we can't, because we don't have the budget for that. The customer pays for a product, the customer pays for experience, the customer pays for cross-functional teams, for example. But unfortunately, telling him like, okay, we need more budget to fix things, this is not a cool selling point. So unfortunately, we are not in the position, unfortunately or luckily, we're not in the position to get ourselves some big servers and let them do the patching for us. So lessons learned so far then, like, okay, installation is easy. I mean, we are development driven, like our developers, they are quickly to make an npm install, and then we've got something on our systems which you don't know about. But on the other side, as I said, various infrastructures, then patching is hard. And the worst thing about it is like, okay, you know about it. You've got a gut feeling like, okay, what is going on, or what may be going on. Then you're looking at HiCD and you read about the news like, okay, there's, for example, cloud bleed, stuff like that. Do we need to patch? Don't know. Don't know where our software is. Don't know what the state of the software is. This is not cool in the end. And so we decided we want to fix that. And we want to fix that in an automatically way. So our approach here is, as every tech approach, like the easy part is, okay, we make some solution for that, some automatic solution, and this contains like scanning for CVE entries. Do you know what CVE entries is? Do I have to explain that one?
Who knows about CVEs?
Okay, cool.
Okay, cool.
So then we skip that. But the important part about the CVEs is it's not about the information, like there's a vulnerability in that package, la 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 la, and attacker may la la la. You've also got the CVSS score, like the Common Vulnerability Scoring System. So this gives you a number, like how much bang for a buck an attacker may gain if he exploits a certain vulnerability. So then we said, okay, we need to find out about the CVEs we have. Like CVEs means like affected packages. We automate the scans then, and we gather all the logs. So this is our information base we have then, and this is the starting point for the tricky part. First, you got to dashboard the things so people are in a better position to understand what you're talking about. Like as I said, there's a CVE description, like, okay, an attacker might gain or might remote execute something. If you go to the developer, he's like, okay, under what conditions? No. We went binary, like, okay, do we have it patched or do we don't have it patched. So, and the best thing about it is you can get to your higher levels, to your managers, and say like, okay, this is what the infrastructure looks like. This is our state of infrastructure. Right? Maybe we need some more money to put on our infrastructure, or maybe we need to buy new stuff. So, then you can take action. You can go to the admins, for example, and say, okay, please have a look at the system. My dashboard says it's got 77 packages with CVEs. And then you can start all over again after leaning back for now. So I hope you're in the right mind so that you know where we went, and I'm going to present to you now what our building blocks are. We ourselves built a CVE scanner to audit our VMs. This is just a 200 lines Python script which talks to a web service I will present in a minute, and it runs every night to check out for the CVE packages, which means it will get a dpkg list, the installed packages from Ubuntu or Debian, and will check for the packages if they're affected or not. Then we had it integrated in our config management, I will talk about that as well, and in our central logging and dashboarding. Our CVE approach was like, okay, let's use vulnerabilities.com. Who of you does know about vulnerabilities? Okay, that's not that few. Who uses it actively? Okay, cool. Then the guys will thank me because we will do a little bit of commercial here. vulnerabilities.com is a we are not affiliated with them, but we found out that they're quite good people and a very good service it is. vulnerabilities.com is a freemium database service with all the security feeds from the major Linux distributions, from the BSDs, and it also has the CVE, MITRE, NVD, the National Vulnerability Base, in it. So this is our authoritative source of information about CVE entries. You can query it via a REST API or via the web front end if you're sitting in front of it, in front of your browser. It even offers the ability to scan systems for you. They've got an open source project where they did something similar to us, but it wasn't fitting to our needs, so we reinvented it somehow, but it's still a good thing. And you also can subscribe to certain feeds. Like, for example, I want to know about the Apache software stack. Okay, please give me information about Apache, and then you will get an email for it. And the best thing is they're parsing all these open information from the Linux distributions, from the CVE, so they don't charge as well. And they're really nice people, meaning in a way, like, if you tell them, like, okay, I need this information, or would that IPA endpoint better, then they're really keen to talk with you and figure things out. And they're also quite good in integrating vulnerabilities into other projects. For example, there's an Nmap plugin. You can use it for burp, that it will check the JavaScript dependencies you have in your web pages. Getsploit is a nice thing I wish I would have had in my diploma thesis, like it will tell you where the vulnerabilities in your software stack are. You see it's similar to what we are presenting here. And as I said, they've got this nice API. Cool. So we've got that. Our approach then, as I said, we get all the installed packages. We sorted to our colleagues, like when we were doing heavy cybersecurity stuff here. And it's always better to have some candy and the construction workers' helmet there to make a good approach. And then, when we got the list of installed packages, we audit them for CVEs entries and get the CVSS scores. We're rather simple with that. Like, we just get the top CVSS score. If a package is affected, we just need to know about the worst vulnerability we have. Besides that, it's not affected, so we don't mind about it at all. A demo by Ingo.
Okay, let's hope that works single-handedly. So we want to show you how easy it is to use that API, because you don't need an account there, nothing. So yeah, I'm using HTTP and not curl because I cannot remember the curl stuff. But basically, you can just send a request there, and you get a response saying, okay, can you read that okay, or should I make it bigger? Like so? Okay, cool. Yeah, you're seeing the response, okay, you're missing some parameters. Okay, then maybe I put in OS Debian version 8, How about that? Okay, looks good, better. Now I need to pass in some packages. I need to tell vulners which packages I have on my system that I want to audit and I want to learn about if there are any CVEs. And depending on your operating system, you just ask dpkg or yum or what have you for that information. And what I'm going to do now is to just pass in one package, a vulnerable Linux kernel. And yeah, then the lights get out, but that's fine, I guess. Then you get all this bunch of information in a split of a second. So all you had to do is send a post request with some JSON. And then at the sudden, you get, yeah, this is how to fix it. And these are the CVEs, which are a bunch of them. And you get a ton of information that you can react upon and put into your logs. To give you a more specific view on that, I'm now piping all that JSON through JQ in order to pass out two fields that are of interest to me. And then you get, like for Debian, the Debian security advisory notices and the CVSS core and also the CVSS vector. And yeah, this is kind of nice. You don't have to spend any money on commercial solutions. You can just use the API. Another thing we did, and which I can show you kind of briefly, we built a CLI tool on our own. And this does all the magic in the background, scanning a host, a special host that I have prepared for you. And then you get just like a summary of, okay, how bad is it on that host? So it SSH into the host, does all the vulnerabilities magic, and then you get the vulnerabilities.
Cool. So now we know what our vulnerabilities are. We have some special tools in place to understand and aid us in our approach. But the problem is, like, okay, we don't want to SSH into every host. We need to centralize this. So we went with our ops crew and said, okay, what kind of configuration management you're using? We're using SaltStack. Does anybody of you know SaltStack? Anybody of you using it? SaltStack. Okay. So the other guys just, the other folks are just with Puppet, for example, or Ansible. Okay, cool. Anyways, we do our orchestration with that, which means you have got the servers. They are the minions in this paradigm. Like they get the configuration from a central master, and not only the configuration. That's the nice part about SaltStack. So you can also centrally send commands to the minions, and the minions then will send the results to the master. So you just have the orchestration cycle there. You can directly from central points orchestrate your infrastructure. And the best thing about it, you can codify your update strategy in it. Like, okay, we know we need to update our systems. When do we know? Then when do we need to update? And is the customer cool with updating, for example, Sundays, or do we need to update during the weekdays? Stuff like that. So we need to have an update strategy which we can then codify. I will go on later into that. So the thing is about the orchestration, as I said, you can codify your update strategy, and we have several requirements for that. And so we can, with SaltStack, match our infrastructure that certain aspects, certain servers, certain stacks only get a certain configuration. Here, for example, you can see that there's a generic templating for every system in the environment. This is with the star. Then you see that every system gets a Vim and has some scripts on it. And then you see two additional matches for web services and for database hosts that you can say, okay, on a database host, I want to install the MySQL, for example, and on the Apache is installed on the web systems. And the minions then will have a configuration like, okay, I belong to the web configuration system, so they will get the Apache installed and stuff like that. And you even have a templating engine because you know that on Ubuntu it's called HTTPD, or on Fedora it's called Apache, for example. So there's different names for different services, for different systems. And as I said, we have several requirements regarding our update strategy, and the ops crew then managed to say, okay, let's have 3 models or 3 flavors of updating our systems. The worst thing about it is, for example, when you do a patch day, like you have to manually look out for patches and have to install them yourselves. So then you have a certain day in the month that you say, like, okay, it's Tuesday, we have to install the patches right now. Somebody has to take care of it. Somebody has to be on the lookout for the results, and then needs to check again if everything works as required. This is, for example, this is why I put the picture of the Neapolitan ice here. This is the strawberry. Nobody wants the strawberry. You want to go for the chocolate, and that's the unattended upgrades. Our system of unattended upgrades on the other side says, okay, we do every day on 12:30, we do our upgrades. Why 12:30? Because after 12:30, the devs or the ops guys will be back from lunch, and then they will see if the systems are still living or not. And not many scheduled meetings are around 12:30, so they might be able to work on the problem then just at that moment. And in between, there's the thing, this vanilla thing, like the orchestrated updates. This is like we have one certain system which gets the update, and if everything is fine, if everything is good, then the update worked, the reboot cycle worked, then it will get logged, and from the logs, the other systems in that cluster will say, okay, our Frontier approach worked, our Frontier system, it's still living, it's still up, it works as intended, our checks are good with that, so they get the update as well. Like then we have our guinea pig system, and the other systems will look out for that. And as I said, we have a centralized logging as well. It was mentioned by Christian earlier as well. Like we have our egg stack, we log everything into that. And the best thing about it is like, okay, we've got it in the Elasticsearch as a database. The Logstash components are on the system, so they deliver the logs to our centralized system. And the Kibana, this is our front end, so that we may show you shiny dashboards. And this is how a dashboard, for example, looks like. This is just a teaser to give you some mouth-watering pictures, and now Ingo will show us some live stuff.
Okay, cool. Let's keep our fingers crossed. It's still there, which is quite nice. So, as Florian mentioned, just one question. How are we running time-wise? Is this okay? Yeah. Okay, cool. Doing all the coding, using vulners, building all that stuff, interacting with the ops guys, that was not that easy, but it was fun, right? But obviously you have to convince your management, right? So if you talk to your manager and your CFO or CEO and start about, yeah, there's a CVSS score of 8.9, we should fix that, that's probably not going to work. Fortunately, we have kind of managers which are into security, which understand that it's important, but nevertheless, we had to build some sort of dashboarding for them and for us as well. So and this turned out to be kind of the hard topic because we tried to put a lot of detail in these dashboards, but in the end, one of the metrics that worked the most, you can see on the left side. So you basically see, okay, you have flawless systems, everything is good, no pending patches. Cool. And then you have tainted systems. There's any patch missing. We don't care what it is because it's not fully patched. And what you are seeing right now as a disclaimer, you're just seeing our sort of internal zone. So no clients that we work for are affiliated to that zone. But nevertheless, we wanted to fix that, right? And get more insight. We also have here, you kind of get the impression that we are not sure about what it's showing, right? Because it's the circle of stuff. Yeah, it does this fancy stuff. It basically displays all the zones. In this case, I only have one. And then just says, okay, I'm going to split down all the findings that you have. Like, okay, which systems are flawless, which are tainted. And then you can just like kind of navigate through here to the tainted ones. Okay, this is one which has a CVSS score of 7.5. This is 5.0. And then you can just sort of investigate what stuff you see there. And to be perfectly honest, some of these things actually work and give you some sort of information that you can use to make the situation better. But the dashboarding thing is kind of hard for us. Another interesting graph is this one here. It shows the number of vulnerable packages over time. And what you see here is that there's a line at the top at 1, which is not that bad, but still. And these are kind of 2 hosts, but they are on the same height. And at the bottom, you have all the rest. When you look at other zones, you will see these lines going up, going down, going up, going down. And if you have such measurements where they don't go up and down, it means that the patch management is kind of broken, right? Because it should fix itself, but it doesn't. And the rest of the stuff is not that important to you. If you want to look at it in more detail, just grab us at the coffee bar.
Cool. And to conclude, this is the big picture, and we have kind of like the circle of life. As I said, we have the engineers, they define the update flavor, and they will put it into our salt master, which then orchestrate the minions. The minions by themselves get the information from vulners directly, and we put it into the log stash then, which will get then shown via Kibana to us as security guys or to the customers who may work with that. And the good thing is we also can query the vulners then to check for further information about the vulnerabilities. So, and as we said, okay, you sometimes need to talk to your manager and say, okay, this is cool stuff, we want to have it. Like, you also can put it in terms like, okay, we have our ISMS, Information Security Management cycle, like we do plan, do, check, act. So this is something he or she might better understand. Or if you are more like into audits, you are afraid that an auditor is visiting you and he wants to find out if you're into ISO 271 or not, then you also can say, okay, we've got a 4 eyes principle. For example, we have our engineer and we have our security person. They are thinking about the flavors and which system gets which flavor. Then we've got our configuration management database over here, and we've got some reports we can automatically get out of Kibana. So then you're into 4 compliance models as well, and you can sell it in an agile way for that as well. But the problem is we're still in the progress in developing our solutions, so we present some limitations to you. And the good thing about it is, as I said, you can go into compliance. You will know about these quirks we are now presenting, then the compliance guys probably won't know that these are there. For example, tails from the kernel.
Yeah, actually, I mean, we wrote software. It has bugs as well, right? But especially one thing that we encounter, because we have thrown this stuff on also on legacy infrastructure, was one thing that is mentioned here. If you look at the output, I hope you can read it okay. It basically tells you that, yeah, there's a Linux image, a Linux kernel installed, not just 1, but 2. And the thing that broke our system was that on that box, on Ubuntu, these Linux kernels are installed explicitly with a version number. If you look at the output, it says Linux image 313, yada, 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 and then in the second column, again, 313, which means the full version number is part of a package name. And on Ubuntu, this caused on that system that, first of all, vulners didn't report any vulnerabilities, which it should because it's an outdated kernel. But then we figured, okay, this box was running the unintended upgrades from Ubuntu, and it didn't get any updates. So it was not, we shouldn't blame vulners for that. It's more like we should blame us for that because we installed the kernel, a package which will never get an update anymore. So we fixed that by kind of installing the appropriate package. Ubuntu has these meta packages, and you see it at the bottom, Linux image generic, no version number anymore in the package name, but then it points to the latest version of the support kernel, right? The second limitation, reboot hassle. It turns out that another system, this time it's a Debian, and this has been with us for quite some time. In fact, it was patched or distribution upgraded from Debian 6 to Debian 7 and then to Debian 8, I guess. Oh no, I'm on the wrong track, sorry. This is again a Ubuntu system, but nevertheless it got a distribution upgrade. You can see it there in the 3rd, 4th line where it says tilde precise 1. Yeah, but now it's running Ubuntu, a supported version. But nevertheless, there was a quirk. It says that there are 2 kernels installed, 3.13.121 and 3.13-137. And the thing is, you got to check if you have an updated package, if it's actually effective, right? Because on that system, still the old kernel is running. You see that in the kind of lower half, the uname-a output, it says the kernel running is 3.13.121, but there's a newer kernel installed, but it's not run. So things you have to look at in that regard are.
With Ubuntu, there's a way that the update tells you if a reboot is required. I can't tell from the top of my head how, but I know there is.
That's absolutely correct. The remark was on Ubuntu, you have a system or a package which will tell you if a reboot is required, and that server has that package, and it got told the last 176 days, yeah, you should reboot, but it failed. So what you want to do is, in order to fix or to detect this stuff, vulners won't help you. You gotta work with your ops guys and just monitor that as a metric, like monitor the uptimes of your servers, which used to be a kind of metric for, okay, this is a very stable server, it's running for decades. Nowadays, it's more like doing the reverse uptime metric. Wow, this has been running for 30 days. We gotta kill that quick and make it fresh again. This is not our idea. It's been, I think the first one who wrote a blog post about it was from Diogo Monica from, I think he's still with Docker, right?
Mm-hmm.
Okay.
So you saw we're quite in the middle of development, and we also have some metrics right now, but there are also some next steps. And the funny thing about it is, yeah, there's always some next steps, like we need to fix some quirks. But also, like, we're a digital agency, that means we work with various tech stacks, and nowadays we're also into the Docker environment as well, also as in serverless. And this is something we want to achieve over the next time, that we integrate our containers there. We know container checking is a hassle. There's some good enterprise solution for that, but on the other side, as I said, we're not that enterprisey, so we've got to go with Claire again, which is an open source tool to check container layers and gives you information about which layer is affected by a CVE package. They do the CVE checking by themselves, and we just need to integrate the results from that, as well as AWS integration. We need to check our serverless scripts, and for that, we, for example, can use NSP. This is the node security project. They've got this nice command line tool that you can use to check your node dependencies. And this is something which directly fits into our environment, which our developers use. And we also can integrate it into an CI process on the front so that the developers will get the feedback, but we also want it in the back, like in our system we're presenting here, that we also have a second information stack that we know, okay, it was really fixed, or what should we do with that. But on the other side, there's also some alternatives which you might use or might integrate into your environment. On the one side, we have OpenVAS. The VAS is the web vulnerability. Open source project, there's something open. And on the other side, you have the salt scanner. This does exactly what we do, but they post the information directly to Jira, so you have a ticket, or they put it into Slack so that you get a message from your friendly neighborhood scanning robot, like your server needs to be fixed. They don't put it into the Elk stack, but they also talk with vulners, and it's also a nifty Python script, so easy to install. Of course, you can also use your typical enterprise environment solution. I'm not into that word, so maybe if you're like into big environments like for SUSE and stuff like that, you can use that as well. And Ingo was already talking about Diogo Monica. His reverse uptime and golden image freshness metrics are the way you want to go nowadays. If the system lives longer than a few days or few hours, then kill it. And on the other side, don't fix it, but get rid of the old image you were using, just update the image and then put this into your environment. And it's everything open source and everything support from vulnerabilities. So we've got to thank Kirill. He was a great guy in communication with us. He was open to our questions. And as we said, vulnerabilities is a freemium model, so you can use it as well. You can get into contact with them via Twitter or mail them directly. And for Sinner's Radar, I got to thank Christoph Trautwein especially, because he was the guy responsible for the orchestrated update model, and the other ops guys as well, because they were open to us running into their offices and like, okay, we need to fix that, we need to fix that. We have a software here that can show you how to fix it, or at least can show you what is broken, please fix it. And they were like, okay. Cool, and so far so good. Thanks from our sides. We have some time left for questions, I think. So thanks for attending here, and yeah.
Okay, thanks, guys. First question from me: how long did it take you to come up with this solution?
The solution that coming up was easy. Like we had every week, every day we had this pain point. Like, okay, we need to do something. This went on for quite a while. I don't know how long. The solution per se, in the technical terms, was like we did it in 2 days.
So the technical implementation.
Yeah, the technical implementation. The hard part about after that was going to our management, going to our colleagues, going to the project manager, and telling them, yeah, okay, we need to do something.
Okay, that's.
Maybe one remark, what kind of helped us to do that technical deep dive quickly was just do a pairing session. So there was not one guy doing the coding, but 2 guys, and we did it in 2 days together. And so if we have not that system right set up, but you want to go into that, I highly recommend to grab a colleague who you like and do it together with him or her.
Thanks for the ideas and for the presentation. My question is, you guys are using CVSS scores, most likely base scores from CVSS v2 or v3, I don't know.
Exactly.
Did you consider including other factors for this prioritization? Which patches should be applied first besides CVSS scores, base scores?
So if I got your question correctly, you are asking if we are using the CVS scores in order to schedule which patches are installed first?
For instance, not only the CVSS base score, but you can use aspects from threat modeling from your environment and say, okay, this, because sometimes CVSS 9 from 2 different vulnerabilities, one of them is a big problem for me and the other one is not. That's why, I mean, besides the scores, using something else like input from your threat modeling.
Understood. So actually we are not doing that right now because we don't have time to do that threat modeling in that depth and that automated way. So the remark is correct. If there's a CVS 10, it may be in a software package which is not running or exposing anything that's not used anymore. But in that regard, we just go the cheap way, patch, and we don't have a model to do the stuff that you are suggesting right now.
Because a couple of, I think 2 or 3 years ago, one company named, I think, Risk.io, they were using not only the CVSS scores, but they were considering, for instance, whether there is a Metasploit module for that vulnerability. And so this is something that might be interesting for you to look at. Thanks.
You have a question? Sorry?
Hi. So you briefly mentioned that node security scanner at the end, but most of the talk was about operating system package updates for Debian and Ubuntu. So what about other package managers for the applications? What about npm, pip, whatever, you name it? You have lots of web applications, and I think most developers will use their own package management and not the operating system package management, right?
Exactly. This is why I talked about the CI approach. We tell our developers to integrate these scanners into their CI so that they will get a check for that from our GitLab system, and that will tell them, okay, your build failed or not. And we deliver them before some scripts, like, okay, please integrate it into your GitLab CI YAML, and it will tell you which of your requirements need update or not. And this works quite well on the forefront, like when the developers are developing. But as I said, on the other side, we want to make sure as well that we have an overview about what is going on. So we want to integrate the NSP check again into our system, and we have it on the back side, because some requirements say, okay, we've got, for example, outdated node modules, but we can't fix them right now. Then the CI check will pass, but on the other side, we don't have a second look on it. We don't have a second opinion about that, so we want to integrate that as well.
All right. Hi. Thanks for the good talk. I have one question, which might lead to another follow-up question, depending on your answer. How exactly are you pushing these update commands through SaltStack? Like, what do they look like exactly? Is it just apt-get dist upgrade, or what exactly are you pushing, and where do these commands come from?
As far as I can tell, it's just apt-get dist upgrade.
But is it the ones that are coming through the vulners info, how to fix it or not?
No.
Damn, because we figured if you just submit a CVE with a command on how to fix it, then we could run code on your systems. All right, so thanks.
Hi. Thank you for the talk. I've discovered a lot of things or problems that we had as well. So like the kernels and all that stuff. But we have a big issue with legacy software that is dropped into the file system via zip or tar gz and comes with a lot of packaged libraries and stuff like that. It's very hard to discover what is in these packages. But for example, when you look at Heartbleed or something like that, you would like to know if the application has a packaged OpenSSL library or something like that.
Yeah, the side-loaded stuff. So obviously we are creating the package manager of the operating system. Anything which is like wget, download, extract, use it, we won't see. A common example that we have encountered is Oracle JDKs. This is something we have thought about but not fixed yet. So in that case, our strategy is currently to review our config management configurations for these cases and then try to change that to use a proper package management system. But you are correct. These are the nitty-gritty details when you talk about patching.
Thank you.
Okay, I hope we answered all the questions for this session, and if there's questions, you will be around after the next talk.
Yep.
And we'll continue here with incident response in this track, and yeah, we'll just take a few minutes for the other people to arrive from the rookie track.